All right, welcome back, everyone. This is demo 4 for abstractions. So to get started, let's actually look at what we're building. I actually forgot to do this for like lectures 3 or like demo 3, but remember the like to-do list app we had. We're gonna be improving this. And remember how we added like subtask to task? We have that already. The third thing we're gonna add is categories. So to give you an example, it's gonna look something like let's say I add a new task like to do my chores, for example. Add the chores task. And the UI will look something like this. You can add subtasks under each task and a category or like multiple categories. So for example, a subtask would be like do laundry. I can add that. So that's a subtask. I can add another one, let's say like sweep the floor or something like that. Those are subtasks. And just to prove it to you, this is on. If I reload like multiple times, you can see the picture changing once again, and it's still persisting. Um, and if I turn on the backend, it'll do the same. It'll still persist. And the feature we're going to be adding this time to this to-do list app is a category. So for example, like these are like tiring chores. I can also add the color for which color I want to add to my category, like that. And you can see it adds like a little tag there. Yeah. Yeah. And you can also delete and do other stuff. But this is what we're going to be building today with abstraction, so no more SQL. And by the way, this is connected to the backend that Resi works. Today we're gonna be continuing off what we did on Monday's lecture. So let's go do that. This one, where is it? This one. All right, full dot, open that up. Let me make it bigger. Okay, so this is what we built last time. Let's just go through really quick what we have. So this is the right one, right? Starter. Oh, this is actually PA2.
It's supposed to be a blank.
Hmm?
I think it's supposed to be a blank.
No, it's the one that we did last time. So let me just open, sorry. To find it first. This is FA25. This should be it. Ah, here it is. Yeah, so we had the db.py last time that we implemented with SQL Alchemy. We have the task model here. We can have the columns here, ID description done. The init function will just create a new object of this class, a new task. Serialize will just return back the object that you are trying to get. And the same for the subtask model. We have the columns, we have the foreign key reference here that references a task ID. We have the init to create a new object, and we have serialize, which is to again get it, like get the object. All right, so today, let's continue. Where are we? Yeah, so today we're going to be doing most of our work in app.py, but we're also going to be adding the categories later on. So let's go with our first route. Oh, let me turn on my completions. Save completions. All right. So we have our decorator as usual, app.route tasks. And then the function get task. All right, this is our endpoint. That. Okay. So this is an endpoint for getting all tasks. Okay. So we will just be calling whatever we have in db.py for this. So it will just use our task model here. In this case, we just want to serialize all the task objects, right? So let me just make a list first called task. We will store all our tasks here. And then for task in the task class, this is some new syntax we have here. So this is this is SQL Alchemy. We can use this dot query dot all. And I think I'm missing an import here. Am I missing an import?
To import the task.
Yes. Yeah, so from on top, I'm just gonna import task and subtask like that, so we can use it in the file. And if we go back down here, yeah, so I make a loop going through all the tasks. So this is querying all. So this is basically like getting all. So select all from task, but with no SQL. And then I will just do task append the object. And here I cannot just append the object. I have to actually append the serialized object. So we're going to use our serialize function that we have because it will return a nice dictionary format of the task. And what this will return last time is I'll go back here. It returns something like this. So it return an ID description done in a nice JSON format, nice dictionary format. And then all we have to do is just return the task in a success response. So just return success response, and that will be a dictionary with the tasks in a list. So I'm just gonna return the list like that. Yep. So yeah, it looks much cleaner. The SQL is all gone. It's all inside that .query.all, all abstracted away behind the ORM. So yep. And also you can actually do this in one line if you want. You can just like remove all these three and put it in one line. No, I'll just do it now. So an example of doing it in one line would just be like me copy this, comment this out. Okay. A one-liner would look like this. So have an array or a list, and then just task equals for task or like T for T in task.query.all, we will just pen T. So it'll just be T.serialize for T in task.query.all. Yeah, so you can see it's much more compact, and we can even do like a one-liner for a simple get request like this. And is everyone familiar with this syntax for list? Does anyone not understand what's going on here? Hopefully everyone understands. So this is like a list, and then you're doing a loop inside the list, and you're just putting whatever the output of the loop is inside the list. So this does the same thing as the 4 lines over here. Okay. And now let's do the create task. So we got the get task. We're going to do create task. I'll copy the header. So it's going to be a route slash task, and then we have methods as usual. Post. We have to change this. Create task. Endpoint for creating a task. Right. So same as usual, we have to get the body from the user. So body equals json.loads, and then that's request.data. And then we want to create the new task object from the body. So I'm just going to keep it in a new variable. New task will be an instance of the task class, right? So we're just going to use the init function right here. Remember, we made this init function to create a task object. So we're just going to put in whatever keyword arguments it expects. So in this case, we need a description and we need a done. So inside this, inside the function here, so I'm just going to create a new task object. And then see, it says here, I need some keyword arguments. I can put the description and the done. And description here will be whatever the user gives us. So it's body.get. And then here it's just key description. And then done will be body.get done. Like that. So that's a new instance of the class. It's a new object. And all we have to do is we just have to add it and commit. So then this is again new syntax using the ORM. It's going to be db, which is our database instance, dot session dot add, and we're just going to add a new task. This. And I believe, do I have db at top?
Remove the
Yes. Let me like that. Yeah, so the imports task sub doesn't db. We initialize the db here, so we have it. Okay. Good catch, thank you. Okay, and lastly, we need to commit as well. So db.commit. So, oh, db session.commit. Commit like this. And then we have to return the task to user. So return a nice success response with it's just going to be the new task. However, it's not just the object. We have to give it like in the properly formatted format, which is the serialized function. So we have to return it serialized. And because this is created, we can uh put the code 201 because this is a create. Does anyone, yeah, question?
So for like we'll
Mhm.
commit on like the db.py and then here you
Hmm.
commit on f.py.
Yeah, good catch. Yes, in this case, we're actually like we're when we actually added here in app.py. So the db.py is now mostly just the connection. We actually moved it, you're right, from db to app.py. There's no particular reason. You can actually move it back to db.py, but I'm just doing it here because it's like we're just trying to keep the db.py clean to just be the model, the creation, and the serialized. That's it. Does that make sense?
Yeah.
All right, nice. Do next.
Okay, so now we're gonna make another route to get the task by ID. So task, and then we're gonna pass in the ID here. So we're gonna get this task, and like previously, we're gonna use new syntax, task, new syntax. So, with the task model, we're going to query, and we're going to use filter by. So this is how we get the specific task. So we know that our task has an ID column, and so we can just use that and filter by the ID. And then there might be multiple IDs with this task ID, so we're just gonna take the first one. This like shouldn't happen, but like we just do dot first, just to ensure that it's one singular task. And then let's check if task is none, then we would return a failure response. Otherwise, we can just return a success response. And here we want to serialize the task, so the client is able to see the task in a well-formatted way. So that's get task by ID. Now we can do update task. So this is going to be another route. We're going to take in a specific task ID and then we're going to make some changes to it. So let me first put a comment. So first we need to get the body information. So we're going to do a JSON.loads request.data. And then we're also going to grab that task. So this is the same as what we did previously, task.query.filter by, filter by the specific task. We're also going to check if the task is none. And then we can actually go about updating our task. So we can do task.description equals body.get description and then task. Wait.
in case.
Oh yeah. So from the body, we're gonna get the description, but there's a possibility that we aren't given a description like value. And in that case, this second parameter here, the second argument is just going to assign the original description. So this is like a fallback. In case we're not given a description, we're just going to keep the task description the same. So we're going to do the same thing with the done. And then lastly, we always want to commit whenever we make any changes to the database. So db.session.commit. And then we can return a successful response.
I have two comments. First off, you see how we're actually just like setting the fields or like the body, like the objects like fields or characteristics, just like a normal Python object. So we're just setting it to whatever the user gives us. So this is another benefit. This is one of the benefits in ORM. You can just treat it like an object and you can just change it just like that. And when you commit, that's when they actually commit the changes. Second, this is actually the last time we'll rewrite the same to-do list app. So after this, we're going to be learning about Docker, how to like zip up your code base and like upload it to the cloud, how to deploy, and afterwards some other topics like images and authentication. So this is like the final form of this to-do list app, and also the same syntax you guys will use in your hack challenge and in the further assignments. So yeah, we're not going to be changing anything else after this in terms of syntax. Right, so that's update tasks. Now let's get to work on the delete task. So it will be the same header once again. In this case, we also take in the ID and we want the method to be delete. This will be delete task. And this is an endpoint to delete a specific task. Okay. So for delete task, we first have to get the task, figure out if the task exists, and then try and delete it. So this will be the same as above. So we're doing the same check again. Get the task using the ID. If it's not there, then you return the failure response. And if it is there, all you have to do is use the ORM, so db.session.delete. And you're going to delete the task. Delete the task like this. So this is the piece of syntax you have to remember, db.session.delete, and it will handle all the deletion for you. And because we're changing the database, we have to commit. So db.session.commit. And last thing is we have to obviously return to the user. So return a success response. And because we have the task from before, we can just use that. Task.serialize, because we need to have it in a nice format. So you can see every time we're sending back to the user, we're using the serialize function. And you can see how handy it is because we don't have to do like the for row and cursor and stuff like that to serialize anymore. Okay, let's delete task. I'm gonna do this, or I'll just do this one. So now let's do the subtask. It's actually test. I think this should work already, but we'll leave the testing to the end. So now let's do the subtasks. So let me actually routes, something like this. I'm going to copy this for the routes here. This is handy if you just want to like separate your code. In this case, we do. So first one is going to be creating a subtask. So it will be the same for a similar decorator. In this case, it'll be subtask instead of task. Actually, no, this should be just task. Because we want to reference which task we want. So this is task ID and then slash subtask go here. Subtasks slash. And the method will be post. But this will be an create subtask. Docstring. So we want endpoint for creating a subtask. Okay. The first thing we want to do is we want to check if the task exists once again. And then we want to get whatever the user have from the body, put it in a new subtask, and then add it and commit. So again, we have this thing. This should really be abstracted out into the function because we're actually repeating this so many times. Now that I'm writing this, but yeah, let's just keep this here just to be completely clear. Okay, we check if the task is there. If it's not, then return failure response. And then we load the body. Request.data. This equals, right? And then we create a new subtask. So the new subtask, I'll just put in this variable, new subtask equals, we're going to use the init function of the subtask class. So subtask class, and inside is the keyword arguments. So let's check what we need. So subtask is in db.py and it needs right here. It needs a description, done, and a task ID. So let's add those. So description will just be body.get the description. And let me make this so it's easier to see. And then we have the done, which will just be body.get done. And then lastly, we have the task ID, which is what we have inside our URL right here. So task ID will just be the task ID that we got. That. Now we have a subtask, and here we just use ORM syntax again. So we just do db.session.add, and we add the new subtask object like that. And then commit, and return. Return success response. Inside, we want the new subtask. So we want a new subtask and 201 because we created something. And I forgot here, but you have to make sure this is serialized. So you use the serialize function when you're returning. Yep. Actually, there's a mistake here. They didn't do 201. Okay. So that's creating a subtask. And do you want to do this one or should I do it? Okay.
Okay, so now we can create tasks and create subtasks. However, when we get all of our tasks, we want to see the associated subtask for each task. And right now we aren't able to do that. And so we're going to add an extra field in the task model to see all of the subtasks that belong to that task. So previously we used db.column, but here we want to establish a relationship with the subtask class. So instead of column, we're going to write db.relationship. And the first field is going to be the name of the class that represents subtask. So it's going to be subtask with the capital S because that's the name of our subtask class. So there's a difference between the name of your class and the name of your table. So just keep that in mind. In this field, we're going to use the name of the class. And then we also have an extra parameter or attribute called cascade delete. So this is important because imagine you have a task with 10 subtasks and you end up deleting that task. So what happens to all of those 10 subtasks? You also want them to be deleted as well. So that's what cascade delete means. So if you have a task with a bunch of subtasks, when you delete that task, it'll cascade that delete to like all of the subtasks. That makes sense. So if the parent is deleted, in this case the task, then all the children are also deleted. So we're going to also, wait. We're also going to update the serialize to have all of these subtasks. So here I added an extra key value. So basically we're going to go through each of the subtasks for that task and we're going to serialize it. That's basically, and it just returns a list of all the subtasks. Yeah. And then I think that should be it. Yeah. Okay. So that's it for the task class and the subtask class. Now we're going to make a new class called category, and this is a way to show you how to model many-to-many relationship. So between task and subtask, that's a one-to-many relationship. But a many-to-many relationship is a little bit different because we're going to have an extra table. So first, let's define the category class. So this should be pretty straightforward. Category dot category db dot model. So here I'm making an ID, which is just normal, and the description, which is also similar, but the same as the other descriptions for the other classes. We're going to add a color column for the color of the category. And then like before, we're going to, actually, I'll do this later. Yeah. And then I'm gonna write an init function. So remember, quargs means keyword arguments. So it's just going to be a bunch of different arguments that we're going to use. So let me make a comment. So here using quargs, we're going to get the description. And then as a fallback, if we're not given a description, we'll just give an empty string. And then we're going to do the same for color. And then we're also going to serialize this. So I'm just serializing the object, just putting it into a really nice format. So now that we have a category class and a table class, and we want to establish a many-to-many relationship, can anyone tell me what we're missing? How do we establish that many-to-many relationship? Trent? That's halfway there, but we need something else as well. Yeah.
We create jointed.
Yes, exactly. So we're going to create an association table. So we're going to just do this at the very top. So we have to make an association table to establish this many-to-many relationship. So this is different than a class or a model. This is just a regular table. And then we're going to name our table association. We can name it like task category association just to be clear. And then db.model.metadata. Yeah, and then db.column. Yeah, so like Tran said, we need a foreign key. So that's what we're creating here. So we're only going to have two columns in this table, one for the task ID and one for the category ID. So here the first field is for the name of that foreign key. They're both going to be integers and they're both going to be foreign keys as well. And we also need to specify which tables we're grabbing that ID from. So here we're taking from the tasks table, we're taking the specific ID column, and then here we're taking the categories table and taking that specific ID column. Yeah. Do you want to do this one?
Right. So we have the association table. Now we want to, similar to how we do subtask here, we want to add the categories to like as a column inside our task table. So here, this is categories, and that will be also a relationship, similar to like the subtask one-to-many relationship. And here we're referencing the category table first because the task it's a relationship between task and category. So we have a relationship to table category. Remember, this is capital because it's the class category. Then we have new syntax here. So secondary equals association table. I mean, this will be our, what is it called? Our tasks. What did you call it? Task. Oh, is this association table? So secondary is this association table, which is our variable. And then we have this other attribute, which is back populates. And that back populates tasks. Right. So this is our categories column. We have a new relationship to the class category. Secondary, this is just to denote or to define our association table. We're telling our ORM, SQL Alchemy, where is our association table. In this case, it's we define it inside this variable, association table above, over here. So we're telling SQL Alchemy which is our association table. And then back populates equals task. This is just to make a bi-directional relationship because later on in the category class, we will also add a line like this that references the task because these are join tables going both directions. We need to have this back populates task. So like the one-to-many, for example, before, this did not have a back populates because one-to-many is usually in one direction. In this case, an association table will be bi-directional, two directions. So that's why we have this back populates. Yep. And then in the category table, like I said, we will be adding this column here of tasks. So later on, what I mean by bidirectional is if I have a task, I can get its category, but I can also get all the tasks related to a category. So both ways I can filter. Yeah, question?
So what if you put like categories in task and then task in categories, but you didn't put back populates?
Good question. If you don't put back populates, you will not be able to filter in one direction. So, like you're saying, we don't. Yeah, if you don't, you're saying you don't put back populates in either of these columns, right? Wait, let me just write this out first. This will be a db.relationship. It will reference the tasks, task class. We have the association table, which is secondary. This, and we have back populates here as well. Populates categories. Yep, that's good. So this is the same line as the one above, but in this case it's inverted. If you don't have back populates here, then you won't be able to reference each other, I believe.
Wait, let's say if you have like a task that says like do homework, right? And then you have a category and you put that task in the category school. then your like task due homework should show up in the task field whenever you call like all the tasks in the school category. But without the back populates, it won't like automatically update. So if you assign school to get homework, it'll update for that task, but it won't update for that category object, that school category object. It won't update all the tasks in that category. Does that make sense? Yeah.
Like a visual example would be like, let's say you have like Instagram posts and hashtags, which is like what this is, like task and category. Instagram posts and hashtags. If you don't have back populates, then you will not be able to like filter, like you filter by hashtag, and you're getting all the posts that are in using the hashtag, for example. Like, yeah, that's like a visual way to understand it. Okay. Any other questions, by the way? Yeah.
But just earlier, what does the if you like go up with the
Mhm.
association table, what does the metadata do?
Yeah, this is similar to how we pass in the model here to the class. We're passing in the metadata. That's just, I personally do not know what's inside the metadata, but it's this context of our model, like our DB model, which is a SQL Alchemy like instance. Yeah. Like I actually don't know what happens if you remove this. But yeah, I'm sorry, I don't think I can answer this question properly enough. Right, and then we have to fix a serialized function. So here in the serialized function for task object, we have subtasks. We also have to add the categories, subcategories, and that will be something like this. But let's just change it to C. And for C in self.categories, like that. And here, this is where a little bit of a complex situation happens. Yeah. How do I frame the question properly?
We do it for the other.
Yeah. Okay. Subtasks. Okay. In the subtask model, let's do that the same way. So we have this category. Yeah, right here. Yeah. So we have this relationship to task. And when we serialize, we want to return all the tasks. So we have task will be self dot task like this. And that'll be for one and like to loop through them. So it's t dot serialize for t in self dot task like that. Yep. Can anyone spot a problem in the way we're handling this? This is a difficult question, but I wonder if anyone can start to see a problem with how we're doing this.
So we're serializing all the tasks in a category. So we're serializing category object, which is giving all the tasks, right? And then in the class, we're also serializing all the categories for each task. So what's the issue when we serialize both objects like this?
Oh yeah.
I think like you end up doing like recursion because you like follow yourself. Because like if you serialize the category, it goes back to serialize the task.
Yeah, that's the perfect answer. So yeah, if you serialize categories, then inside the like what it returns, you're returning all the tasks. And then in a single task, it returns all the categories and it keeps on looping forever. And in the end, you have this recursive function that so like you'll never return the user essentially.
Yeah, so it'll be an infinite loop basically.
So how we like go about this is we have to stop somewhere. So let's do it in the category class. We're gonna add a new function here that we'll just call it a simple serialize. So simple serialize. And what the simple serialize function will do is it will return a serialization similar to this. However, it won't return the tasks. That's literally the solution we have. So let's copy this. So simple serialize will have everything except the task. That way, when we're calling a task, we get every single category without the task. Like each category doesn't have like the infinite recursion. But if we want to get all the tasks inside a category, we can just call the normal serialize function. So we just separate those two so we don't have an infinite loop. Yeah.
Fix the task.
Oh, yep. And above here in categories, right here, instead of serializing the category for every single, instead of serializing the category, we just do simple serialize here. Like that. And this will stop the infinite loop from happening. You gonna do this, or I will go through this really fast. Okay, so the last thing we want to do is we want to have the ability to actually assign categories. So assigning categories, it's as simple as adding a new row in our join table. Remember how last time we used join tables because inserting is all one time. It's really easy to insert. We just add a new row in the join table. So in this case, we're going to add an endpoint for adding categories. So here, we're just going to change this to assign a category for task with this ID. And here is going to be a category route. Category. And this will be our category routes. That. Okay, and then the method here is post because we're adding something and we want to take in the task ID. So this is the endpoint for assigning a category to a task. Right. So again, the first thing is we have to check if the task exists. So we copy this one again. And then we want to get the user body. So we have this line as well. As you can see, like we're at this point, we're just using like the building blocks we already had to make these like logical processes in our function. And then here, let's just get it just for the sake of simplicity. So this body.get description. And then we have the done as well. Oops. Sorry. Oh my God, I did this. Done, like that. So we get description and done. Actually, wait, sorry, this should be color. So we get the description and the color of the category. And then we want to create a new category object if it doesn't exist. So here, just name it category. Will be a new category instance. And inside this, I actually have to import it. So let me go out and import our category here. That. The category instance will have the description, which is the description we already have. The color is also the color that we got from here. And then all we have to do is task.categories dot append. So we just append it to our list of categories inside the task object itself. And here, because we have to check whether or not the category exists already, we will just do this. If category is not none, and we will get the category here using a query. So category.query.filter by the ID or by the color. And the color could also, okay, let's do this first. Okay, this is a bit confusing. Let's go through this. Actually, let me finish it first. db.session.commit as usual, and then return the success response. This is task.serialize because this is a task object. All right. So over here, we have the task here. We check if it's not there, and then we get the description and the color of the category. And then over here, we're actually trying to get the category if it exists. If it exists, then we don't run this line. We don't add the new one. I mean, we don't make a new one, and we just use the one we already have. But if it is none, then we can actually create the new category, and then we append it to our task, a categories list inside the task object. So if you look in db.py, the task object has these categories here. So we're just appending to this list. Yeah.
The app.py, do we need to do the db.session.add category or no?
No. So in this case, we don't add it because we're not, this is different. This is a table, not a class. The way we add it is a bit different. So we just append it this is like we're treating it purely like an object at this point. So we're just appending that category to the list. Yeah. Yeah, and this should be it. And ideally you would test it, but we don't have time. Is there any more questions? I will just be starting the code at this point. Nope. Okay, let's continue. Yeah, and if you connect it to a front end, it will look like this. But yeah, let me stop the recording.